Hello everybody, welcome to my channel. Today we have a very good problem for you guys. Call it building with ocean views. These are very good problems, so make sure you pay close attention to the problem statement, right? So it says given in, we're given n buildings, right, in a line. We're given an integer array height of size n that represents the height of the buildings on the line, right? Okay. So the ocean is to the right of the buildings, okay? A building has an ocean view if the building can see the ocean without any obstructions, okay? So formally, a building has an ocean view if all the buildings to its right have a smaller height. Very interesting that they told us that, right? And they bolded for us so that we can really pay attention to that statement, right? So it says to return a list of indices, zero index of buildings that have an ocean view sorted in increasing order. So she's a very good thing, right? So pretty concise problem statement, right? So what they're pretty much saying that we're given this heights array, right, which represents the height of each building, right? And there's an ocean to its right, the right of the buildings, right, the right to the far end, right? And we want to see which one of them have the, pretty much can see the ocean, right, without any other building blocking its view, right? And he says an ocean can see the ocean if there are no obstruction and no other buildings that are blocking its view. So let's go through examples to help solidify, right, the understanding real quick. So we see that so for example, right, we see 4 so building 0, right, which is the index 0, this is what we're going to return, right? Building 0 has a height of 4, right? And it says that an ocean has a view of the ocean, right, if there are no buildings to its right, right? Because that's where the ocean is, right? To its right, that has a greater height, right, than it, right? So if all the buildings to its right are smaller than its height, then it can see the ocean, right? So that's why building 0 can see the ocean. Building 1 cannot see the ocean because height of 2 because of 3 blocking this view. Because you see that 3 is greater, right? And it's to the right of 2, right? Building 1, right? So therefore it cannot see the ocean because of that, right? Okay. And 3, and then this building, right, can see the ocean, which is building 2, right? Can see the ocean of index 2, right? Can see the ocean because, right, to its right, it's only 1, right? 1 is smaller than it, so it can obviously can see the ocean, right? That's kind of how and 1 can see the ocean, but it was the least value here, right? You can see the ocean because there are no buildings to its right, right? So by default, it just can't see the ocean, right? It's kind of what it is, right? There's nothing blocking its view, pretty much, right? And that's kind of how all the examples are, right? That's kind of what they're doing here, right? So how can we go ahead and solve this problem, right? So it says that a building can see the ocean if all the values to its right, right? All the buildings to its right have a smaller height than it, right? So what I can do, I'm taking straightforward here, right? Without being clever. For each building, right? Try to find if they're try to find if all the buildings to my right, if they're smaller than I am, right? If they end up being smaller than I am, right? Meaning that I encounter a building of a height greater than mine, right? If that's the case, then I can see the ocean. I'm fine, right? So that's kind of what I'm doing here, right? So if there are no other building to my right, right? Then I can say, I can see the ocean, right? So for example, we do for building 0, we check the rest of the array, right? For I plus 1 onwards, we keep checking, right? And then when we get to building 1, we do the same thing. We check the I plus 1 and on to the end of the array, right? Trying to see if we see that any building that's greater than it, right? So make sure that all the buildings are smaller, and I only add them to my output result if that condition satisfies, right? If I encounter that, no, I didn't encounter any bigger height, which means that all the height are smaller than I am, right? Which is a good thing. So you can see that it wouldn't fly pretty much, right? Because for each iteration, we would do, check the remainder of the array, right? We keep checking over and over again, right? We're doing kind of some sort of a double for loop, which is not pretty efficient, right? Because let's think about it. If we had like a very big array, like a, size million or whatever, right? Imagine doing that, right? And O n squared is not going to cut it, especially in interview setting, right? It's not going to cut it, but it's a good way to, start thinking, maybe to kind of point you in the right direction, right? Because you see that for every iteration, right? We're trying to find an element that's greater, right? That would break that condition, right? So if we don't encounter any element that breaks that condition, then it tells me that I can see the view, right? So doing it over again is not gonna cut it. Maybe since we're already going to once in the array, right? Maybe there's a way we could like, capture some sort of a data, right? So let's say we take we did the first one index, right? We loop the rest of the array. Maybe we could store some data somewhere that can help us in future iterations, right? And you using that information to help us in solving that, right? Because doing over is not gonna cut it, right? So let's go through my drawing board, guys, right? I think we can it can kind of help us in coming up with an efficient way of doing this, right? Okay, so we're going from left to right, right? Trying to find every time an element that's greater, right? If we don't end up finding an element that's greater, then it tells me that I can greater than I am, right? It tells me that I can see the ocean. Okay, and I do that for every building, right? No, it's not good. So maybe we're gonna have to switch our approach, right? Maybe we can just walk, you know, in reverse order, right? From right to left, right? Maybe starting from the ocean itself and seeing which buildings are able to see the ocean, right? Maybe as we're looping through, we can capture, right? Maybe the maximum building, right? The maximum building to going from right to left, right? Okay, so that's gonna allow us to. So if we capture the maximum to the maximum going from right to left, right, looping from right to left, right, it tells us it's gonna tell us a couple things, right? For example, right, uh, capturing so that in every iteration, right, we'll be able to reference that verb on that max variable, so that we will reference that max variable, allowing us to know if we can see the ocean or not, right? Because each building is going to ask, right, am I bigger to the maximum element to my right, right? If I am, right, it tells me that I can see the ocean, because if I'm greater than the maximum element to my right, it pretty much tells me that I'm bigger than all the elements to my right, right? Because that's the biggest element to my right, right? So I just want you guys make sure you understand that, right? So the goal is, right, is that instead of going from left to right, right, and every time trying to find like, if any element's bigger than us, right, we can go from right to left, capturing the biggest we've seen so far, right, at every iteration, right? And then at every iteration, right, for the next iteration, right, we're going to use that information, right, to know what is the biggest element to my right, right? The biggest element to my right, if I'm bigger than it, right, then I can confidently say that all the elements to my right are smaller than I am, right? For example, right, let's go through an example real quick so that it can make sense to you guys, right? So we would have some sort of let's do this real quick. I think it'll be better. Uh, so let's say max so far, right? Let's call it that real, right? So we're gonna have max so far, right? Looping from right to left, right? Looping from right to left because we want to know that information, right? So going from right to left, we capture it at every iteration, guys, right? So max so far for the first iteration, right, will be 0, right, initially, because there are no building, right? No, to building 3 of height 1, right? There's nothing, right? So we compare, is building 3's height, right, of 1, right, is it greater than the max so far, right? Yes, it is, right? So we would add it to have an output result here, right? We would add that idea uh, of that thing to the output result, right, with 3. So and then we update the max so far to 1, right? Okay. So now I get to building 2, right? I see it as a height of 3, right? And I'm like, am I greater than the max so far, right? The maximum so far that you can see from going from right to left, right? Because by the time you get to me, right, it tells me that that's the maximum of all the values to my right, right? And having that information allows me to make confident decisions, right? Because I can say, all right, if the biggest element to my right, I'm bigger than it, right? Then I'm bigger than all the values to my right? Because I'm not capturing the second biggest or the third biggest, right? I'm the top, the biggest element to my right? Because that's the way that I'm going about it, right? So I get to this one 3. It's greater, right? So we add its index to it. It's terrible writing. All right. And then I change that to 3, right? Because every iteration I'm updating the value, right? And then I get to in building 1, right? I see that it's not greater than the max so far, because the maximum value so far to my right is a 3, right? Since I'm not greater, then I can know that. So if building 2 wasn't here, right? And it would have been added, but because of this building that's there that's blocking this view, it can't see it, right? Yeah, capturing the biggest so far, going from right to left, right, can make us make that decision pretty much, right? Because even if there was another building blocking my view, let's say for example for two, right, we had an extended array here, right, and it was like let's say we had a height of 8, right? So you can see for two, right, 3 is blocking his view. This one also blocking the view, right? But this would have been so far, it would have been 8. Max so far would have been 8, right? Right, and it's still yeah, it would have still worked, right? Because it can't see it, right? So it doesn't matter if 3 is also blocking, building 2 is also blocking his view. It doesn't matter because this big old building right there is already blocking his view, and that's all I care about, right? If any of the buildings, right? That's kind of what you guys need to think about it, right? So we capture that, and then we just go ahead and if we skip it, and then we go to this one, we see what's the max to my right, right? Max to my right is 3 because I conveniently have this right there, right? Then I can say, ah, cool, then I'm bigger than it, so it must be bigger than all the elements to my right, which means that all the elements to my right are smaller, right? Per the definition of the thing, right? I can easily add myself to it, right? And then at the end, guys, what we do is simply just return this, right? Since they wanted an increasing order, we just go ahead and reversed, and it will return it, guys, right? As simple as that, right? So let's quickly go into the code. I think it'll make even more sense to you guys, right? Once we get into it, right? So we're gonna have a list of integers, call results. Okay. Array list. All right, so we're gonna have x and max so far, right? Looping from right to left, right? Max so far is equal to is 0 initially, right? We're gonna loop through is equal to height minus 1, but that's the is where equal to 0 and minus. Okay, and then we're gonna check, guys, right? The if this particular height, right, is greater than the max so far, right? If that's the case, right, then I can go ahead and update max so far to equal to that height, right? Like we were doing earlier, right? And also add it to our results here. That at that particular index, right? Because it's what we're storing here. And then after we do all of that, we just do a reverse, right? Remember that I showed you guys, right? Reversed result, right? So after it's been reversed, right? What we need to do, because since they want to insert an integer int, right? Array, right? So we're gonna create our output, which will be results that size. Okay. And then what's next for us is just to populate it, right? However you want, right? So we could have, yeah, let's do it this way. All right. I is less than res.len I plus plus. Okay. Do res of I is equal to results. Because we were just converting it. All right, looks good so far. After that, we just return the result, right? So I guess kind of the whole gist of this algorithm, right? We just loop through, we capture every iteration, right? If we compare it with the maximum so far, coming from right to left, right? If it's greater than the max so far, right? Which means that's the biggest element to try, right? Then it just adds itself to the output result and also updates the max so far, right? So that in future iterations, it other buildings can use that information, right, to decide if they can see the ocean or not, right? Because being bigger than the max so far to its right pretty much tells me that I'm bigger than all the elements to my right, right? So this is a very popular thing that other algorithms uses a lot as well, right? Talking about monotonic stack and all the different problems as well, right? That uses this exact same technique. So pretty good thing to add to your tool bag, right? So what up here? Right. Oh, know how to spell. Okay, it's good enough. Press run. Okay, looks good. Let's press submit. Awesome, guys. Looks like we passed all the test cases. If you guys found value, you guys understood the thought process in the comment section. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.